Who's gonna go first? I go first. Somebody go up there. Go first. All right, go first then. Like I said last week, my presentation is gonna be all about the camera and stuff, learning ID, face ID, everything with the learning machine. Give me 1 second. All right, face recognition. So everyone knows it's face recognition. They can detect your face and give you the unique ID. It's work for the company, the big company though. But based on that idea, that I use a camera for the home system, so we can detect the face of a family. So everyone in the families, it will learn your face time by time, give you the unique ID, have small information about you. Example, female or male, race Asian, white or Indian, black. It's not racist though, but your name related into the house. So all of this is will be put it on the house. It will be understand your face every time you get home. You don't worry about someone in your house. It's just basically get to your home and the camera will scan your face even in the dark because we have a night vision. So it will scan your face, everything. Example, some stranger get into your house or outside of your house, so they will notification that a stranger and will give a voice warning and stuff. That's face recognition. So detect strangers, smart voice. So we have some speaker outside the house, so we'll be warning the guy stranger with outside. Well, this is feature we can study to learn about the mailman too. Basically, the mailman just drop off the stuff, so they will know the mailman because everything is published. It's on the data information. In that time, I think we can put the face recognition on the car. Basically, like that picture, we have the small camera on the mirror, so it will scan your face every time you get in. If it's not your face, so basically, someone else, so it cannot start the car, or it cannot do anything with it, even though you have the key. This feature is pretty good for feature. Example, you have a kid or someone. Example, the kid then, like 17 or 16 years old, they have a key, so they get your car and they go away. With maybe causing accident and some mess. So this will learning a face again. Will be asked you. Will be reading whenever you start the car. It will know you. Okay, here. Your name and stuff. Where do you want to go? Like that. Prevent the thief. Basically, a stranger. If you get into the car, want to start the car, have to be enter the passcode or something. And will be save that face, for the future. If you're allowed to get into the car, so you have the passcode to start the car. The other thing that's for the business though, we can use a camera for business. We can use a face recognition for business, like I said last week. It will learning like friendly, get into your house, or learning professor, and will be no information about professor, or recognitions of people from everywhere. It will detect your face is drunk or not but that possible because they know lots of people want to do that option. But will be in the future though. Remember, long times ago, we watching a lot of movie. They have a lot of face recognition by criminal and stuff. So they match the face with the fingerprint and stuff. Basically, right now, I think it's a feature. We have a face recognition with the camera everywhere. So you cannot get like your child or something will have the face recognition whenever it got kidnapped or lost somewhere, so they can find out the location, the last location they got kidnapped or something. So who kidnapped them or something. So that is pretty good for investigation too. For the investigation purposes, they can have your information right now. If the police want to pull your records, they just one click to pull your record. But they couldn't see, the face recognition right now. The camera is pretty, neat. They can scan you far away, from mile away. Example, the Google Lens, they have a learning camera, so you can scan your stuff with the Google Lens, but you cannot scan your face with the Google Lens. So basically, the Google Lens will know the products and the item, but it's not about the sex or the face. Yesterday, I discussed with the manic. I scanned the manic's face, it doesn't show anything. So basically, the data doesn't have any information of the Indian, Asian, black, or white people. So basically, we import them into the learning machine. We'll be learning one by one. Example in the future, the camera will be know, oh, that guy is African American, tall 1.7 feet or something, or Asian guy, Asian dude, tall 6 feet or something, stealing the car is an Asian sex. So basically, that get close to investigation, so they will know who is this. In the future purposes, they will import face recognition with information that help for investigation. Basically, camera everywhere, just scan it. They will know who making the mess. So that's my research. Any question?
So you said something like, well, that right there, it says face drunk or not. How do these cameras, what's the technology behind it that'll actually allow something to detect whether a person is probably another person or whether somebody is probably drunk? So let's just use that as an example. How would you tell if somebody is probably drunk or probably not drunk?
Because
take me through the process.
Because first of all, when people drunk, the face is gonna get redness. If not get redness, the eyes is gonna be changing. So the normal eye, when you get into the car, everything, the face is normally, so the car will be start. But if you change something on the eye, like you get tired, we'll ask you, okay, you want to get a nap before you get it driving or something. Look at your face, look like you drunk, so you have not the option to driving the car unless you wash your face and come back, try again.
Right. So you're talking about how a human being would do it. I'm asking you, what's the technology behind this camera that would determine, like, how would you actually create a technology? So we're talking about machine learning here, that would detect whether somebody was drunk or not. What's the process?
The process, we're gonna import some face, that's because it's like right now you can import the fruit from the good and bad and stuff, like Amazon they doing right now. They can detect the food is bad, the food is good. So why don't we do the import the face, like redness or the drunk face in the database, so it will be scanned your face every time.
How many faces are you going to bring into the database?
Well, a lot.
Okay, so you take a picture of a whole bunch of people, right?
Yes.
Some drunk, some not drunk.
Yes.
But somewhere you're going to keep track of who's drunk and who's not drunk?
Yes.
Okay. And then now you have that data in the database. What do you do with that data?
So we're gonna scan, because of the learning machine thing is gonna scan your face every time,
Before we even get to that though, before we can, so you have pictures of a whole bunch of people that are and are not drunk, right?
Yes.
Now, ultimately, our goal is that when you get into the car, the camera's going to look at you and determine, are you allowed to start the car or not, right?
Yes.
What's the process in the middle? How do we ultimately get it so that camera can look at you and determine whether or not you are probably drunk or probably not drunk?
Well, because the thing is, whenever you get into the car before the process, you have to scan your face to activate the system. Mm-hmm. So first of all, you cannot okay, I'm drunk and I'm buying the car. The dealer is not going to accept it. You have to be a normal guy to get into the car, to buy the car. And when you scan your car, first activate the system. So that is first picture, that is we learning from the machine. So you already have.
So what's the point of having all those pictures of people who are drunk and people who are not drunk? How's that being used?
Yeah, because it's like the drunk people can be the face of changing or something, like the face is changing for, like they can take a picture of you before drunk and after drunk. So that because getting machine to learning about that important to the data. So you have your face before and after drunk. So the faces will change. So another day we'll take another picture from the people the same with it, drunk and before and after drunk.
How's the face? As an individual, a person might not always look the same when they're drunk. So you can't operate it off of a single picture, right?
Yes, and that is why the voice the voice recognition has come too handy.
Well, but that's kind of the same thing. At the same time, somebody who's very drunk might not be slurring their words, but somebody who isn't drunk at all might be slurring their words. So kind of what I'm trying to get at here is we want to look at how does machine learning actually work. The idea here is that if we just use this idea of drunk versus not drunk, and this is related to what we'll be doing in the hackathon, just as a group, as a class here, do we feel like if I showed you a picture of somebody, okay, could you make a guess based on that picture whether you think that person is drunk or not drunk?
Yes, we can.
How many of you think you'd be good at that?
70%.
You think 70% of the time you'd be able to tell whether they were slammed?
Yes.
Okay. What about the rest of you? Think you could, at a picture, you think you could tell whether somebody was drunk? Maybe. Do you feel like that's something that some people would be able to do?
Some people do.
Okay. So where I'm going with that is this idea that, so we're going to start off with this hypothesis that we think it might be possible, given a picture of somebody, to detect whether or not they are probably drunk or not. We think that might be possible.
Yeah.
So now the idea is where does machine learning come in? Well, what we need to do is we need to get, we'll just create a data set. Let's just say we have 10,000 pictures of people. Okay, and 5,000 of them are drunk.
Yeah.
5,000 of them are not drunk. All right. So we need to know which ones are drunk and which ones are not drunk. And now what we're going to do is we're going to train a neural network.
Yes.
On that data. So we're going to feed it a picture. The neural network's going to guess, is this drunk, not drunk? If they get it right, we leave it. If they get it wrong, slap them on the wrist, adjust the weights a little bit. So overall, then we keep feeding the data. So you get this neural network, this model, balanced for detecting the kind of the pattern of what a drunk face looks like. Make sense? Okay. Now the idea is that if our hypothesis is true, if there's something that if there's something about a person's face that's drunk versus something about a person's face who's not drunk, whether or not a person who maybe is good at making that detection or not could articulate it, they might just look at it and say, yeah, I think you're drunk. They might not even know why they think that. They just think that. That kind of indicates there's this underlying pattern of what does it mean to be drunk. So what machine learning would do is you would train this model up, and the idea is this model would attempt to fit that pattern. We don't even have to understand the pattern. And then what you would do is you would feed that model a picture it's never seen before. Okay, so maybe we bring people in off the street, we take their, we have them go into a breathalyzer to find out whether they're actually drunk or not. Then we take their picture, and the model would say, yay or nay, drunk or not drunk. And then we'd be able to look at the breathalyzer and say, does the model guess right? Does that make sense? Okay, so the idea here is that for this camera, when you get in the car, for you to look up and it scan your face and this stuff, for it to be able to make that guess, okay, because it's effectively trying to categorize you in one of two categories, drunk or not drunk, okay? Then you could, that model would have had to be pre-trained with a whole bunch of drunk and not drunk faces.
Yeah.
Now, so maybe that's what happens when it's right out of the box. Okay, but beyond that, what maybe happens is now to make the model even better at working with you, because the model could be stored in the cloud somewhere. Let's say, maybe at your house, because a lot of people might buy a system like this because they truly want to care about their safety, right?
Yeah.
Maybe when they're completely hammered, they care less about their safety, but when they're completely sober, like, if I was thinking about it right now, I don't want to get behind the wheel drunk. So at home, maybe whenever they drink, they take a picture of themselves, and maybe every night they take a picture of themselves. Sometimes they're drunk, sometimes they're not drunk, and they hit a button or something like this. But they're effectively further training that system with their own data, making it just a teeny bit more able to detect them.
Yeah.
Okay? We've already kind of trained the system with a pattern of a drunk human versus a non-drunk human. Again, with the theory, the hypothesis that that's a pattern that can be discovered.
Yeah.
Okay. You might find out after testing that maybe with machine learning, it determines that every single Asian person is drunk. Okay. So it might be that it's not can't fit the problem, right? But it's worth trying. It might be that whatever factors is the pattern. Maybe it's really, really good at determining white people.
Yeah.
Maybe it's white males. Maybe it's really good at determining white males being drunk, but you start throwing in data from females or different nationalities, and it just doesn't do as well.
Yeah.
Okay, so kind of the point here is that the camera is a good idea for doing that scanning, potentially, but we have to understand the underlying computer science and what that camera's feeding off of.
Yeah, so the other option that I talked to my friend, the cool function about, because it's like the drunk or not drunk phase is, I write in just kidding because it's possible they can do that by learning machine, because they scan your face, it's drunk or not drunk, because the learning machines will learning.
Mm-hmm.
Well, it's possible the machine will have 70% to get it right. But if it's get it wrong by driving up the people, like usually if you're drunk, you're driving recklessly, like driving something, the machine will be learning. Oh, this guy drunk.
Reliable enough for that particular.
So this guy drunk, so just okay, you have to pull over and stop, or the car will pull over and stop itself.
Yeah, but again, this is all depending on how reliable it is for that particular model. Well, where we start drawing some comparisons. Do any of you watch the show Silicon Valley?
No.
So that's be a bad example, but there's a funny thing in that show. It's actually a really good show from a computer science person's perspective, because it's all about startup companies and computer science people writing software for stuff. And there's this one guy on the show. He's this Asian guy named Jin Yang, and he's kind of a comedic relief in the show. But he has this. He gets this millions of dollars in capital funding because he creates this app that's supposed to determine whether it's supposed to be a food detection app. The idea is for the dieting industry is how it was sold.
Okay.
It can determine whether something is good for you or not good for you, something like that. But actually, what the app he actually produced did was to determine whether something was a hot dog or if it was not a hot dog. But the point is it uses. That's machine learning, right? It fed it a whole bunch of pictures of different hot dogs, and then it fed it a whole bunch of pictures of things that are not hot dogs. Let the thing trained onto, can I determine the difference between a hot dog? And all of us in here feel like that's a pretty easy thing to do, right? For a human. Okay, but the purpose of machine learning is to try to get a computer program to make some of those decisions like a human would be able to make it, even though we can't necessarily articulate. If you look at something, I say, is this a hot dog? You would all say, no, it's not a hot dog, right? And if I ask you, why is it not a hot dog? That's a harder question for us to answer, isn't it? You say, well,
it's not a meat.
Cell phone. Not a hot dog because it's a cell phone. But now you might have to start going into well, how do I know that's a cell phone? How do I know it's actually not a hot dog? Maybe it's just a really weird looking hot dog. You see what I'm saying? It's harder for a human being to really determine why we don't believe this is a hot dog, even though we're 100% positive this is not a hot dog. Get it? So the purpose of machine learning is to find that pattern when a human being can't articulate it. That makes some sense?
Yeah, that's just why the Google Lens.
Yeah. So the punchline with like, drunk or not drunk is, while it might be able to detect some patterns, it might not be accurate enough to be worth it.
Yeah.
And especially when we already have kind of systems for determining, there's cars when people get a DUI or something, there's cars that come with a breathalyzer built into it where you get into the car and you
if you have the
breathalyzer, it won't like turn the car on.
Yeah, because if you have alcohol, you falls on the breath detection example that, because you can call your friend, hey, can you do that for me? This is
But the point is, we don't need the camera if we have a breathalyzer.
Yeah.
The breathalyzer is going to give us our actual blood alcohol level. Well, not our actual, an estimated blood alcohol level. That's probably going to be more accurate than a picture of you in questionable lighting or something like that. But the point is still made that with machine learning, we can make determinations for these different things. So having a camera take a picture of something and make a determination of what it took a picture of is all about what machine learning does.
Yeah.
Okay, good. Next.
Jordan. About cancer. I know that.
I think you probably saw the email or the message on Slack and stuff, but if you're interested in the machine learning bootcamp thing I'm doing, it'll probably be in here on Monday night at 6 p.m. I'm guessing it'll be a couple hours, 6 to 8, something like that. But I will record it anyway, so if you aren't able to make it but you're interested in it, I'll have a video up because that's the stuff we'll be doing for the hackathon. All right. Go ahead.
So last week I was interested in the article using machine learning and Markov models for cancer diagnosis. However, I couldn't find a lot of articles with like a similar way of doing things. So I found one article or a couple articles about diagnosing cancer, and then a couple that were more cancer related, but they still used machine learning algorithms for it. So my first article was regarding the detection of early colorectal cancer. And they created this machine learning algorithm for the study called colon flag. It's actually been used in the United Kingdom and Israel, but they wanted to test it out using the US population and under US insurances for whatever reason that would make a difference. But their big goal of the study was to see if the machine learning algorithm worked differently with different subgroups and different, like different groups of people. So the colon flag is based on decision trees and cross-validation techniques, which allows it to predict the likelihood that someone would have colorectal cancer. It works with 4 functions. The first one is it batch processes the input files of patient data, and then it validates these files to a proper structure, logic, and confirmation with the program that it's running. It then calculates a score for each patient and then creates an output file with a risk score for each patient. After analysis, it was discovered that the best detection was in the cecum and ascending colon, and then it was less effective in the transverse colon, and then even less effective in the sigmoid colon and rectum. So basically, it was still significantly better at diagnosing through any part of the colon, but there was like a certain area in the colon where it just worked better for whatever reason.
Is it operating off of pictures? Is it operating off of X-rays or MRIs, or where's the data coming from?
Oh, sorry. So it's just input from data. You need the gender and the birth year of the patient, and then at least one complete blood count. So just one complete blood count would be like a whole comprehensive blood examination, basically. Mm-hmm. They found that there was in the past, there's been statistics that find that like a certain percentage people are at risk when you're anemic or when you have hemorrhoids. So it takes this comprehensive blood count, at least one of them, and puts that into the structure of the colon flag, and that's how it determines it. So people that have more than one complete blood count analysis, it's more effective in determining that, but it kind of just goes off the statistics of different aspects of your blood would lead to different risk factors for colorectal. Yeah.
Okay.
And then it also found that the detection age range for this process was 40 to 89 years old compared to the 50 to 75 years in like the previous ways of detecting it. And they found that it had a significant advantage over models solely based on age. And they were pretty happy with it and found it to be feasible for the US population in addition to the other two populations that it was already working in. My next article was kind of an overview of using machine learning in breast cancer diagnosis and prognosis. So it kind of started with a background in the machine learning, but then it went into detail with the 4 forms of machine learning. So with the artificial neural networks, support vector machines, decision trees, and k-nearest neighbor. So these are just like generic diagrams. The first figure, the one on the left, it's the support vector machine model, and basically it creates this margin line, which is just the largest separation between the two classes. So the only thing that the support vector machine can do is basically split it between benign and malignant. And so that's how it kind of pops out with that one. The second figure over here is the artificial neural network. So it takes into account the 6 inputs, which is basically just different cell information. So if you would have a tumor, it would just take the information of the size, thickness, whatever, and put it in as an input with a hidden layer with 8 neurons, and then it would give it the diagnostic outcome with that. The one on the left there is the decision tree model, and it can use both numerical and categorical data, but again, it uses the cell information and then tells you whether it's malignant or benign. And then this colorful one on the right is the k-nearest neighbor depiction. The blue circle is the test sample. The green triangles show malignant breast cancer tissue, and the pink squares show the benign breast cancer tissue. But after that, the article kind of went into a synopsis of the last like 2 or 3 decades of how they've been using this information regarding breast cancer. So there were some really specific things. It was oddly specific and yet lacking in information at the same time, if that makes any sense. So I didn't include anything else from that, but I thought the generic models were pretty interesting to see how they apply the 4 of them. My next article was about the prediction of persistent pain after breast cancer surgery. So they found that people that got breast cancer surgery for breast cancer within a year there were like a fairly high percentage of people with persistent pain, which is something that is better treated when caught sooner, just about everything. So the machine learning has 4 steps. The first one is establishing an output space. It creates the different classes for patients with respect to their pain. And then the second step is the feature preselection, and the different parameters are analyzed with respect to either persisting or non-persisting pain. The third step is feature selection. So the parameters distinguishing between the persisting and non-persisting pain are eliminated unless they provide additional information to include with the study. And then the fourth step is the analysis, so the classifier is created. So this classifier is a rule-based classifier, and it's used as a diagnostic tool, and it's comprised of the 3 variables: demographic, psychological, and pain-related parameters. So for this study, they actually did It was made up of a bunch of like surveys almost that patients would fill out, and it was on a like pain scale was on 0 to 10, but they also did certain psychological surveys, ones that are fairly well known in the psychology world. So there was like a depression survey and things like that. So they compiled all these things together, and they found that this new method showed improvement in correctly assigning patients to either pain group, persisting or non-persisting. The next article was the prediction of arthralgia with breast cancer. So for hormone receptor positive breast cancer, the use of AIs is really critical, and it's not artificial intelligence. It's aromatase inhibitors. So it's a type of medication specific for this type of breast cancer, and it's really it's critical to use it. However, arthralgia is a toxicity side effect of using aromatase inhibitors. So because of that, it leads to a lot of non-compliance with medications. Arthralgia is joint pain. So they find that they want to do this study because a lot of people stop taking their medication because when they take it, they get joint pain. So for this study, they were analyzing SNPs, so SNPs, they're single nucleotide polymorphisms, and they were trying to determine if there was any subset of SNPs that would predict whether or not someone would get this toxicity side effect. So the machine learning algorithm used fold change and Fisher's ratio, and they found it to be an effective identifier of the prognostic and predictive variables with the SNPs. So they categorized the SNPs into 3 groups, basically a positive, negative, and then one that was kind of like it's here, it could be here and there. They then ranked them by their discriminatory power in decreasing order, and then they used an algorithm with recursive elimination to kind of narrow it down. So they ended up determining the amount of details necessary to differentiate between the classes of a positive arthralgia and a negative arthralgia. And they took it from about 400,000 SNPs down to like 400, and then they further classified it down to 70. So they ended up finding 70 of these single nucleotide polymorphisms that can predict with fairly high accuracy whether or not someone will get this toxicity side effect.
This is before they take the drug.
Yes.
The AI thing is effectively a drug.
Yes,
right?
yeah, it's a drug. Yeah. And then my last article is about the detection of lymphedema in breast cancer survivors. So lymphedema is the swelling in limbs, so arms and legs, and it just comes from a lymph system blockage. And they find that's pretty prevalent in surgery cases, and there's really no cure to it. So the sooner you catch it, the easier it is to treat. And I don't know if you guys have ever seen a lymphedema, but it's literally like it just keeps growing and expanding. If you watch My 600-Pound Life, a lot of them have lymphedemas in their limbs or their backsides, just from the blockages. It's kind of interesting. Anyway.
What is it? Is it like a big fat roll or something?
It pretty much, it's like, if you ever see someone that has just like this huge like swelling, and a lot of times it's not balanced. So they could have swelling in their right leg and not in their left leg.
Okay.
So like their left leg would look completely normal, and their right leg, their calf would be like the size of their thigh. Yeah. So it's not enjoyable when they have it.
Mm-hmm.
So they gathered patient info from the optimal lymph flow mHealth system, which allowed for a real-time symptom report for patients. And they used the machine learning to detect the presence of lymphedema. So basically, previous ways of detecting it is from doctors just noticing it. So you can catch it, but it could be there for like years before you actually notice it. So this is kind of their way of taking these symptoms in early and trying to detect it as soon as possible. So they classified patients between the positive and negative. and then used a set of 26 symptom features to help with that classification. And that's basically like if you have swollen fingers, if you know, different things that you would notice visibly, they just put it into a feature subset. They compared the use of 5 machine learning algorithms, decision tree C4.5, decision tree C5.0, gradient boosting model, artificial neural networks, and support vector machines. And then they found that the artificial neural networks had the highest performance accuracy. They kind of analyzed it with 3 categories, and all of the artificial neural network ones were higher than 90%. But they found that the rest of the models performed significantly better than the original way of analyzing it. So it was kind of a win-win, no matter what they used. And then I kind of noticed searching for things that machine learning algorithms are really popular now with this mHealth movement. And in all the articles, they had really positive results. They were effective with diagnosing and, you know, preventing things. So I can see machine learning algorithms being used with a larger variety of medical issues in the future.
Yeah, so this is kind of evidence, you know, even what we just talked with Van's thing is all of these are similar, right? You know, every single one of them is saying, okay, here's some medical condition, here's the data that we're able to gather related to this medical condition. Can we draw some conclusions about that medical condition based on this data that we can we draw some conclusions prior to when we would have drawn the conclusions before? Like a good example is the medicine one. You know, somebody might give you look at the back of a medicine and it says, okay, here's the possible side effects, right? Now, I mean, some of them are, you know, may make you drowsy, you know, that kind of stuff. Well, that might be whatever, but some of them are really harmful side effects. So it'd be really nice to be able to determine if you are potentially one of that 3% of the people that gets the really bad side effect before you put that thing in your mouth. So if they, you know, so if enough data, you might need to have a bunch of people suffer first, but if you can gather that data and make it meaningful data, even if a human being can't discern that, okay, well, whether this is going to make you sick or not make you sick, building that machine learning model to make that decision before you ever swallow the pill. So I think that's kind of fascinating stuff, and I think you're right. We're going to see machine learning be really popular among, well, I think period. You know, it's going to be popular across the board, but in healthcare, there's, you know, so much guesswork. You know, I can't tell you how many people I'm friends with who, you know, they're in and out of the hospital and they get all frustrated with the doctors and they think the doctor's incompetent and stuff, but the reality is that we don't know as much about medicine as we could, right? You know, and you might have a really gifted doctor, but he's still operating off of what he knows and maybe what the books he has know. Where something like this could really bring together that knowledge pool into a centralized decision making, well, maybe it'd be kind of more a decentralized decision engine that pulls together the knowledge of doctors from everywhere to make some of these decisions. So I think it's really cool stuff, and will probably make us all healthier than probably also make us take less good care of ourselves than we already are doing, because we have the, you know, at some point they'll have the IBM Watson commercial where, you know, some guy is, you know, just sitting there drinking gravy or something like that. Like, well, you know, you're going to have a heart attack on Wednesday, so we're going to need you to come in now so we can go in there and clean out those arteries. So these are now the commercials are like, you know, they're there to fix the elevator because the elevator is supposed to break next week. You know, that's what IBM Watson does now, you know, because it's determining based on the machinery and, you know, number of times it's gone up and down, you know, when it's likely to break. Well, we're going to start doing that with
people.
So it'll be interesting. All right, good. Isn't machine learning stuff fun? No.
Why you?
What's up?
You can pull his laptop with the wire.
Oh, just trying to choke you out.
What I'm going to do on the hackathon related to Monday?
Well, Monday is me teaching how to do machine learning stuff with, we're going to be using Google's tool called TensorFlow.
Okay.
And then that's the tool we'll use actually at the hackathon. So anybody who comes to the thing will be get the crash course of what you'll do at the hackathons, and now you'll have a starting point mentally for that.
Right. Any project that you in mind?
Yeah, we'll talk about some potential projects, and I'm going to provide some data sets for the actual hackathon.
Yeah, hello.
I love smart contracts.
Hello. Today my topic is smart contracts.
Your name, man.
He's just kidding. We know it.
Yeah.
Go ahead.
So smart contracts are nothing but it's a self-executing code which runs automatically when based on when some certain conditions are met, which are coded in the smart contract. These smart contracts they run on top of blockchain technology. It's not mandatory that smart contracts only work with blockchain. It can also potentially work without blockchain technology with some other protocol, but blockchain makes it easy for smart contract creations. So we can use smart contracts to send any value like a token or stock or some stock or some land registration, anything of value can be. And so so these are the properties of a smart contract. So since the smart contracts can run on the blockchain, they acquire the immutable property of blockchain. Once and something is placed on the blockchain, it cannot be tampered with easily. Another is self-executable. The smart contract will run automatically when some event or some conditions are met. So and it's self-verifiable in the sense we don't need some third party to verify the contract. Since blockchain is a distributed public ledger technology, it can be verified by the network itself without a single third party. So what are the benefits of using smart contracts? One is transparency. Since there is no third party involved here, everything is done on the public ledger. There is it has transparent, and the entire system has transparency, right? And time efficient, because a manual contract usually involves some process and several intermediaries intermediate entities in between. So we can eliminate all these things, so it saves time. And precision. So with manual contract, there is always a possibility of some. So who are the governing entity of the contract making some mistakes? Not the contract can be executed even when all the predetermined rules are enforced. So but with the help of smart contracts, since this is done automatically, everything is precise, that the contracts get executed only if all the conditions are met. And trust, since as told before this, that we don't need a third party entity for trusting the network. Entire blockchain technology, there's a technology for to verify the transaction. And also we can avoid paper documentation. So what are the potential applications of smart contracts? Smart contracts can be used is best used in the places where there is some business activity where it requires some kind of contract, some kind of governing conditions in order to take place that activity. So it can potentially have different it potentially has different applications in different fields, like insurance. uh, claims claims uh, the insurance claims process is a tedious process. Uh, uh, before someone claiming the insurance, uh, all the required conditions should be met. That process should be is handled manually most of the times, and the customers have to wait for to get their claims. But with smart contracts, say certain vehicle, say there is more car insurance, say there is certain accident happens to the car, say if that information is uh, say with some verifiable entry, say police has entered that car detail into the public ledger. So since there is a smart contract that so and so accident happens, it will get the uh, automatically it can claims will be issued automatically, can be issued automatically. and and it can be used in government tendering process, this which I've discussed in last week, to ensure transparency in the system. And same goes to the land registry. It can be used in real estate industry, where um, so it does not require third party agents. We don't need to trust third party agents for the registry. And supply chain management, another application is like as entire logistic operation involves a lot of entities. Like if we get some package from Amazon, it comes from some third party. So there is a big process. It can come from different, it will go from one entity to another entity. So if we record everything on the smart, everything by blockchain to smart contract, if the order is lost or something happens, we can know where that order is stuck. Entire entire operation will have transparency, like mm, so that the blame only goes to the responsible entity or person. And another is employment contracts. So uh, this is between employer and employee. If uh, during a job offer or something, we can entire contract can be placed on the offer letter can be placed on the smart contracts, like other details like salary details, and many other things. So this will be transparent, and it can be verified in future anytime. Also, it can have applications in crowdsourcing applications like GoFundMe. Instead of, if someone wants to get some funds, instead of trusting some other third party sites like GoFundMe, we can have a mm, transparent platform with the help of uh, smart contracts. If someone wants to so and so money, he or she can request that money can create a smart contract for that amount of money. Only once that sufficient money is done, that then only the money can be transferred to the requester. So this ensures transparency in the system. So Ethereum. So Ethereum is also a public ledger technology platform like Bitcoin. But one important distinction is that it supports why it has become popular, because it supports smart contract much more easier way than compared to other. That is because it supports Turing complete script programming. Unlike Bitcoin is not Turing complete scripting. Turing complete script program is complete machine is nothing but a system where we can program anything possible, anything computationally possible. So Solidity is a programming language which we can use to which is a scripting language which can use to create smart contracts. So it's in this language, contract is nothing but it's nothing but a class in object-oriented programming language. So whenever that contract is deployed into the network, so the when it is nothing but it is analogous to creating an object for that contract, for that class. So this is some sample program which I've got in the smart contract. Right. This is in Solidity programming language. So we guess under this there is a concept called gas in Ethereum. So it is a metric for saying what are the computational resources required for that network, for that smart contract or what transaction to execute. Because if we don't have any metric for computational resources, some small script can run infinite can run infinitely, and it will take the network bandwidth. So gas limit. So for each contract, we'll have a gas limit, a limit, computational limit that is called gas limit.
What do you think about voting?
Voting.
Smart contracts be applied
Yeah,
to,
that is voting.
this is kind of related to, obviously this week with our midterm elections and things like that.
Yeah, I forgot to include voting.
Yeah. How do you see it working for voting?
Yeah, it is suitable for voting.
Do you have kind of an idea on how you could use a smart contract for voting? Like,
I haven't seen the code completely, because there is some example code in Ethereum. Ethereum, I haven't seen it completely, but
yeah, I think that's going to be a big deal. It just made me think this week. I was walking into the building on Tuesday, and there's a couple of ladies walking in, and this is like at 7 in the morning, and one of the ladies like, maybe it was 8 in the morning, something like that. And the lady was like, the line was 2 hours long. I couldn't even vote. Like, it just seems ridiculous that they make it inconvenient to vote. So you either have to wait too long, or like for me, I technically live in the village of Grafton. So there's a church about a block from my house that was a voting location, but not a voting location for me. My voting location was out in the boonies somewhere in the opposite direction. Because in Grafton, even though it's a small place, there's a town and a city of Grafton. No, village and town of Grafton, two separate things. So they make it so confusing just to be able to cast a vote when we can log into our bank account with dual layer authentication from our cell phone. Seems like we could probably figure out a technology base for voting and have the vote count come in much quicker, probably much more accurate. All sorts of things like that. So, that's I predict that the future of voting, as soon as we can get past the political sides of things, where the old school voting tactics we have now are more manipulable, which is why I think they aren't going away. Yeah, that's I guess my conspiracy theory on it.
Yeah.
Where if you have a system that you can mess with, let's keep that around. I found it funny that I think there was some election where it was a really close election. It might have even been the governor in Wisconsin election.
Oh yeah.
Where there was a whole bunch of votes that, like military votes, that didn't get counted yet because the ballots were damaged.
Oh. This year it was very close.
This week
it was very close.
Yeah, but the point is that every single election, there just randomly seems to be a bunch of damaged ballots. A bunch of damaged ballots, and this is before. Well, I mean, you may have been alive during this, but back with the George W. Bush's, when he was first elected president, they several weeks after the election is when they could finally make the call for who won, and they had all these things about hanging chads and some of that, what, because you would punch a hole through the paper, and if the hole wasn't clean all the way through, and you had a little Chad hanging there, well, does that count? Did they vote for who they thought they were voting for? It's just all sorts of stuff like this. It just seems like
That paper ballot at that time.
every single election we have this, just all of this, I don't know, zoo-like behavior around voting, where it seems like as technologists there are better solutions that would every bit get us an as accurate of a vote. I feel pretty confidently in saying it would get us a way more accurate vote way more quickly.
Yeah.
It would make TV less, I think, fun to watch though, because as you're watching, the vote unwind on TV, the news is like, with 31% of districts reporting, it's a neck and neck race, something like that. I always kind of found that fascinating, but yeah. So I think smart contracts are going to be a big deal moving forward. If we can get out of our own way, I think it'll be a major part of the future. All right, cool.
This
All right.
is why we want to have face IDs come up with. Buttons with your face, recognition, information, you can vote. You just stand on the camera. I vote for that guy. Yes, I'm sure.
What's the saying in Chicago? Vote early, vote often. It's like a saying. Chicago is kind of known to be a fairly corrupt town. So every election you have a whole bunch of dead people that vote.
What?
Oh yeah.
Dead people?
Oh yeah.
So they would get someone's identity.
Yeah, they're taking the identity of dead people. And
so that is why basically, the face ID comes in handy.
well, not unless not if they steal their face. They put on their face. Yeah.
Because the thing about